So far, we've talked about using Sarsa with function approximation. Let's continue our journey through approximate control methods and look at expected Sarsa. By the end of this video, you'll be able to explain the update for expected Sarsa with function approximation and explain the update for Q-learning with function approximation. Let's see how we can turn Sarsa into expected Sarsa when using function approximation. Recall the update equation for Sarsa. Sarsa's update target includes the action value for the next state and action. Now recall that expected Sarsa instead uses the expectation over its target policy. To compute the expectation, we simply sum over the action values weighted by their probability under the target policy. This same expectation can be computed even when we use function approximation. Let's see how to do this. First, recall the update for Sarsa with function approximation. It looks similar to the tabular setting, except the action value estimates are parameterized by the weight vector W. We also have a gradient term to distribute the error to the weights appropriately. Expected Sarsa with function approximation follows a similar structure. We compute the action values from our weight vector for every action in the next state. Then we compute its expectation under the target policy. And that's all we have to do to change Sarsa into expected Sarsa. Now, how do we do this for Q-learning with function approximation? Fortunately, Q-learning is a special case of expected Sarsa. In Q-learning, the target policy is greedy with respect to the approximate action values. Computing the expectation under a greedy policy is the same as computing the maximum action value. So the Q-learning update with function approximation is actually quite straightforward. We just use the max in place of the expectation. And that's it for this short video. Today, we introduced expected Sarsa with function approximation, and we also showed how to extend it to Q-learning with function approximation. Next time, we'll think about how to do exploration with function approximation. Until then, don't get lost.